Math, Minecraft Computers, episode I32, where we are talking about a register. A register is something that stores what we would call byte of data. It can be a 4-bit, or it could be an 8-bit, or 16-bit, or 32, as you recall our experiment over here where we put all 64 bits available. You can see there's a lot. In this case, this device that we built is a D-type flip-flop. You can see it right here. It stores a single bit, just one bit. So if you wanted to register, you would need 8 of these. So we are going to start again with the D flip-flop, where it has a data line, an enable line. If you remember the activity, as I set a 1 or a 0 on this, there is a 1, and then I press the enable, and it will store it. This is our storage of the bit right here. It shows that a 1 is stored. If I put a 0 in and then enable it, you can see that it goes away. That's a 0. So if we have 8 of these and a little more circuitry, we are set. But today we are working in Logisim. Okay, here we are in Logisim, where we built our D-type flip-flop with our final version being this one right here. So just like in Minecraft, I'll go to simulate mode. This is the enable, or the data line. I set that to a 0 or a 1. This is the enable line here. So I put a 1 here, I enable, and you can see that we get the 1 stored here. So our purposes, we don't need Q prime in this. We don't really care about it. We'll take it off. So there's a 1 stored, and there's a 0 stored. So this light is off for a 0 or on for a 1, and that is our bit. Now, if you recall that these are labeled, these are inputs here, and this is our data, and this is our actual enable. What we're going to do is I'm going to call this D0 for data 0 as our label. And then I'm going to grab these two and drag them out just a little bit like this. Now, what we're going to do is actually leave this. And I'm going to enable that as right instead of enable. I'm going to label that as right. And then the same thing, we're going to get rid of our output because we don't need it. Now, we'll take this whole thing and recopy it. I'm going to click up here and right-click on that. That is the name of my file, which is an I32 for the episode we were in register. And I'm going to say add circuit. I'm going to call this circuit register. So what this does is it creates another circuit, another blank breadboard for me to work on. And I'm going to paste. I'm going to bring this all the way up here to the top. Now, once I have that, I want to disconnect this. I'm going to leave this connected, like so. I'm going to move this out of the way, and then I'm going to copy this. Now I'm going to leave one gap right here. I'm going to make sure everything else is lined up exactly the same. Leave one space there. And then I'm going to copy this. I already have it copied. I just need to paste it. And now I don't need to worry about that gap. You see I've left space for there. So I want to do 8 of these. So let me get that done. All right, so here we are. We have 0 through 7. And now all I have to do is relabel these really quickly. All right, there we have it. So now we have D0 through D7. That's our 8 bits. And then the other thing I'm going to do is go ahead and line this right up to this one. I'm going to bring it out. And then I'm going to start right here and just make sure that all of these are connected. Looks like I don't have them all lined up. So let me fix that first. It's like starting right here, you see that we are off. This needs to be moved over to there. And we're ready again. So now we're going to take this line and drag it all the way up to here. Now you see I've got a connection for every one of these. You see that dot denotes. Remember, this is our enable. The center, the 2 center inputs for this. So we now have our right here. And I'm doing it because I have one little tiny wire sticking out. So let me relabel that as right. Okay, so there's our right. Now, the other thing that we want to do is we want to be able to read these particular pieces of data using another input. So we put an input here. That's why I left that gap that's right there. I'm going to line it up with that. And this is called read. Now let me show you something. I'm going to grab an AND gate and I'm going to face it to the east. I'm going to drop it off here. And I'm going to grab an OR gate. And I'm going to, might as well just go with the narrow one for this too. I'm going to drop it off here. We want a 2 input gate for simplicity. There we have it. Now I'm going to create 2 new inputs, just as a little demonstration here. And we're going to run this to here. And we'll do the same thing. Now you see, with a wire coming from a device, I can split it as many times as I want. As you see, I've actually got all these wires running off here. For this particular one, it's going to be a little bit different. I'm going to move this up to here so it lines up. And I'll do the same thing. Get that connected to the OR gate, this connected to the AND, and there we go. So now we have 2 different conditions. I'm going to run these out up here like this to an LED. And so we'll go to our input and output and we'll grab an LED and we'll put it there on the end. All right, so when I go to sim mode, nothing is a problem. And now you see that I get an error over here. This indicates that I have an error. Okay, so why is that? And the reason why is very simple. Watch if they're both turned on. Then I don't have an error. So if you can figure that out, anytime we have an issue, we get a red over there. And it's only when they're both 0, we're fine. If either is a 1, we have an error. Or if they're both on, we're fine. So if you think about that, in this input set, both of them are off. So we have the same value. This is off and this is off. And same thing here. Now they're both on. The OR gate is on and the AND is on. But in the other situation, when I only have one end, the OR is on and the AND is off. So you cannot take an output of 2 gates and combine them onto a single wire like I did over here on the LED. Because how do we know which one? Is the LED representing the off state of the AND gate or the on state of the OR gate? We can't do that, so it generates an error. So what we need to do instead is introduce a new gate for you. Under here, you'll see down here is a control buffer. So let me disconnect this and this, and I'm going to grab one of these control buffers, and I'm going to put it this way. It's going to face east. And I'm going to drop it off right here. And then I'm going to connect it in place like this. I'm going to bring this wire out straight down to here, and I'm going to put an input on it that is facing north. Okay? And then I'm going to do the same thing with this other one. I'm going to make a north-facing control buffer. I'm going to put it up there. And I'm going to drag its third connection down to here, like so. And then I'm going to connect that to that line like this. Now, the way these work is you kind of think of this like a switch. So here I have an on condition going into this buffer and an off condition going to this one, coming from the AND gate. And since these are in place, I no longer have an error there. Now, I can select which one of these I want to show up on the LED. If I click here, I'm saying turn that one on, and you see now I get my 1 coming from the OR gate. If I turn that one off and turn this one on, well, I get my 0 coming from the AND gate, so nothing really changes. If I turn both of these on, I get the error condition again, because once again, I have a 1 and a 0 going to the same line. So this is, think of this as a switch. I want to say, I want the output of this one. So right now, the switch is off and the signal stops here. Now it is on and it passes through. Same thing down here. I could set them both. Neither though they're both on, but as soon as I select this, I get the on state. So that's what a control buffer does. And that's how you have to, if you want to have multiple outputs on the same wire, that's what you have to do. So we're going to want to do that. So we're going to put a control buffer for each one of these 2. In this case, we want it facing east. Now, We're going to drag the read wire out to here, stop it right there, and we're going to connect it to this one, and then bring it all the way down to here, where we're going to connect it into there. Now each one of these is going to connect. There we go. Now, when I go to sim mode and I turn this read on, you'll see that all of these are now enabled, and we're good. So the last thing we'll do is I'm going to drag a line out of each of these to a certain point, say maybe just. And now we can see their state. So there they are. We can easily now say, how does this work? So let's say we want to put just the two outer and the two inner. So we want data bit 0, 1, and 6 and 7 on. And we want to store that. You remember what we need to do is we need to actually now hit the right. And then turn the right off. And then we can do a read. And you can see right here, this one is on, this one is on. These four are off, and these two are on. So it stored our value. Let's do another one. Let's turn everything so that every other bit is on. Only the even numbered bits are on. So that is bit 0, 2, 4, and 6. We hit the right, turn the right off, and hit the read, and you see 0, 2, 4, and 6 are on. So this is how a register works. We have an 8-bit value we store in the data. When we hit right, it moves down and gets stored in the SR latch right here. That value is latched and stored. And then we can read it by using this read. Now you remember the last thing that we needed is we had to have the actual clock, because we want this all synchronized. The way we're going to add the clock here is I'm going to add it there, and I'm going to put an AND gate right here. And I'll drag these two up, move the clock over to here. I think I'll move the right to there. And then this is going to go to the clock, and that is going to go to the right. Now I'm going to turn the clock on. Okay, there it is operating. I think I went a little faster than that. Let's go with 1. So there it is, alternating. And we can hit read anytime we want. Let's go to sim mode here, and it will hit read, and you can see the value currently stored in there. We have some errors because we need to write something to it. So let's just write all zeros right here. So all I have to do is hit the right, and then wait for the clock. And now you can see that I have all zeros stored in there. But that's not a problem anymore. Turn the read off. We don't even know what the values are, but we can actually see the state of each one. Since this is our queue here, we see that they're all off. Let's go ahead and do the center 4 bits. 1, 2, 3, 4, leaving the outer 2 bits on each side off. Now remember, when I click right, nothing will happen. There, I clicked it very quick. You can see nothing moved because I didn't wait for the clock. So I click it, I wait for the clock, and we're set. Now I can read it, and once again, there's the 4 inner off and the 2. So now we have a working register. The last thing that I want to show in is how we are going to set this up as a separate component. So we move this back. I'm going to put outputs on each of these. This is an output pin right here. And I'm going to call these O, then followed by their bit number. So this is O0, and I will get that done. All right, there we have it. We have our outputs 0 through 7. We have our inputs or our data 0 through 7. Now the thing is, we have a clock running here, and the clock is part of the circuit. We don't want it to be part of the circuit. We want it to actually synchronize with every other circuit. So we delete the clock, and we make this also an internal input, and we're just going to call it clock. So there's our inputs. We have all of these as inputs on this side. And we have these as outputs on the other side. Now, what's really neat about any logic simulator is I come over here and I click, and it says this will show you that edit a circuit's subcircuit appears. Let me click there. And it has set that up for us here in Logisim to look like this. You see down here, if I click on that, it brings up a mini map of the circuit down here on the right, and you can see that that is highlighted, D7. So as I walk up these, you'll see that each one is highlighted differently. Click there. And we also have our read and our write pins as well. So there's our read pin, there's the clock, there's the write pin, and there's D. These then, of course, are the output pins. So I'm going to grab these because we can change the shape, and I'm going to move them down to here. Get that last one as well. This is, as you'll see, tells you the anchor, and it anchors east. So I could rotate this and tell it which way I want anchor, but we're going to call this an east anchoring. So this will be what was considered east. I could also change it to north and say that is a north anchoring, which to me, for most chips, makes more sense. I like to think of them in their long point. And then this is our last output. So you look here now, 0 through 7. And then I'm also going to drag over these two. That's D0. We want to leave it where it is. This is the write, and this is the clock. And then I can move the data down to there. Now, of course, I can actually resize these if I want to by selecting segments and redrawing, but I'm not going to do that. This is good enough. I can leave it. So over here, we have a D0, and there's the actual read. I want to get the clock, which is there. I think I'll put the clock on this side and the read on this side. And then we drag D0 down to here and the clock up to there. Okay, so there's the clock, there's the write, and the read, and then here's our outputs, and here's our inputs. And so that's what it looks like as a subcircuit. Now we're going to go ahead and right-click here, and this time we say add a circuit. We're going to call this register test. Okay. Now what I can do is I can click here and drag that onto here. You see I've got it north facing, so there's our circuit. So what this actually now represents is all of this circuitry right here. So all of those inputs are here and all of those outputs are here. If we go back to our test, we know exactly where they are. There's our clock, there's our write, our read, these are our outputs, these are our inputs. So we just have to wire these up. So let's get some south-facing inputs. This can be our two read and write. And here's the read. Now for inputs, we need 8 of those pins. So we'll just start them right here. Like this. And now for outputs, let's just output these two LEDs like you might have on a computer from the 80s or 60s or 70s. This is why they use LEDs, because you can actually read data. You're actually just looking at the on-off state of the various components they are connected to. So you can think of this as an 8-bit byte, the least significant bit to the most significant bit, like we're used to seeing bytes. And then we might as well do some labeling here so that we know what these are. This is the write. Let's get that label on the north. This is the read. You separate those just a little bit so it's easier to see. All right, there's our write here, and you can always verify that by just hovering there. Of course, we need clock yet, so let me go into wiring. We're going to grab the clock and connect it up. You see it's still enabled, so it's ticking. So now we've got everything right. Here's our D0 through D7. Let me just label these each very quickly to make that D0. And the label needs to be on the north. And we're going to call this D7. Also label on the north. There we are. So now I can put whatever I want here, just like before. Let's do every other bit. I should be able to hit right here, wait for the clock. And hit read, and there you set. So you see, it doesn't matter what these are. I can modify these, change them, whatever I want. That value doesn't change. Okay? There it is. It's currently every other. Let's just modify it to be the exact opposite. So there we go. Wait on the clock. Press read, and there it is. Now we read it, and you can see it's the exact same pattern we have here. But of course, now I can change this. So that is a working register that we've done in Logisim. And next, we will build this in Minecraft in the next episode, I33. Give me some likes if you enjoyed. Subscribe if you want more. And it's just a little more interesting than normal, our first component, a register. I hope you learned something. This is Imroy, out.